Hi everyone, this is a second video, and in this video what I'm going to do is do some examples, more complicated side on implicit differentiation. This way the examples would involve many steps and reminders of different derivatives, so I thought it would really encompass a lot by not just making it very baby. Okay, so the first example, we have this relation between x and y, and we want to find dy dx. Okay, so let's take a look. What do? Well, what we need to do is go from left to right, or whatever you want to say, differentiate both sides with respect to x. Okay, so it's nice to write down roots as powers, so we will write d dx of 3x plus 4y raised to 1/2 for the left side. Then we have this derivative of a sum on the right, sine inverse of y squared minus e to the minus 4x. Okay, well, the left side, you have a function. Don't look at what it is. Right now, all you know is there's some function or some relation of x and y with the power of 1/2. How do you differentiate it? Well, the half comes down, and you'll have the same function raised to 1/2 minus 1. But what was inside wasn't just x. It was a function of x and y. So what we need to do is then throw in the derivative of the inside by the chain rule. Okay? And the right side, I'm right now just going to write it as a sum of derivatives. Actually, difference because of the minus. Okay, all right. So come back to the left, and the power 1/2 minus 1 is negative 1/2. So that is 1 over 2 square root 3x plus 4y. It just looks prettier when you write it down like that. Now, what's the derivative of 3x plus 4y? Well, that's a derivative of 3x plus the derivative of 4y. Okay? And what's the derivative of sine inverse of y squared? Well, the outer function sine inverse. Let's not worry about what's inside. So what do you have? It'll be 1 over 1 minus whatever you're taking the sine inverse of squared. Okay, with the square root times the derivative of the inside, which is y squared. Okay, and then minus, what's the derivative of e to the minus 4x? It'll be minus 4 e to the minus 4x. Okay, all right, well, let's put this together. And now you also remember, every time you're differentiating a function just in y, you will have to throw in a dy dx. Okay, what's the derivative of 3x with respect to x is 3. What's the derivative of 3y with respect to x? 4y with respect to x? Well, you can think of it as the derivative of 4y with respect to y times a dy dx if you like. What's the derivative of 4y with respect to y? It's just 4. And then you have to multiply it by the dy dx. Equals, let's just write down this root in a nicer way. It's 1 minus y to the 4th in the square root in the denominator. What's the derivative of y squared? It is 2y, but it was a function of y, so you have to throw in the dy dx. Okay? And then combine the two minuses as a plus, and you have this. All right, let's expand it out. We are asked to find dy dx, so we have to solve for dy dx and bring all the dy dx terms to one side and remove the factor in front of it. Okay, so these two have a dy dx. Bring this over here. That is over there. We'll bring that to that side. Okay, so we have dy dx. And I'm bringing this over here, putting a minus. Let's also cancel this and write that as a 2. And minus 2y over square root 1 minus y to the 4th. Okay, and that equals 4e to the minus 4x minus 3 halves with the square root 3x plus 4y in the denominator. Okay. All right, so now you can solve for the dy dx by dividing both sides by this. Well, it looks kind of messy. You could do some algebra and simplify it. If you want, let's just first take a common denominator on both sides. So you have a square root 1 minus y to the 4th and a square root 3x plus 4y. In the numerator, it'll be 2 square root 1 minus y to the 4th minus 2y square root 3x plus 4y. Okay. And on the right-hand side, what do you have? Take a common denominator, and you'll have 8e to the minus 4x, square root 3x plus 4y. Make sure you got that, minus 3, because this thing's over 1, divided by 2 square root 3x plus 4y. Okay, it's easier to solve for dy dx when you have a common denominator like that. So you have dy dx equals, what the right side is, 8e to the minus 4x square root 3x plus 4y minus 3 over 2 square root 3x plus 4y times the reciprocal of the term next to the dy dx on the left, so square root 1 minus y to the 4th, square root 3x plus 4y, divided by 2 square root 1 minus y to the 4th minus 2y, square root 3x plus 4y. Okay? All right, just simplify stuff a bit. What do you have? These two can cancel because it's multiplied. All right. And then put it all together. And what do you have? 8e to the minus 4x times square root 3x minus 4y minus 3, all of it times square root 1 minus y to the 4th over 2 times this fraction. So if you want, you can write it with the 4 outside or distribute the 2. It doesn't matter how you want to write it. So that is the dy dx. Okay? It looks complicated, but really maybe the most complex part might have been making sure you have a common denominator and flipping the fraction correctly. Okay, but other than that, it's pretty straightforward. what you do step by step is anytime there's a y, be on alert, because when you differentiate that term in y, you have to make sure to throw in a dy dx. Okay? All right. So next, let's look at this function. It's got a pretty graph, so it's kind of nice. Not really a function, a relation in x and y, so you can see there's many different curves. We want to find, if you pick any point, for example, you want to find the slope of the tangent. Okay? It could be many different points. So what you can do is just find a general function that tells you what dy dx is in terms of x and y, and if you pick a point on the graph, you can plug in those points and get your slope. Okay? All right, so let's do this. So you have differentiate both sides with respect to x. Okay, so you have d dx of 10 xy, okay, equals d dx of 3x minus 4y. All right, let's just split the right. That's d dx of 3x minus d dx of 4y. Okay, and the left side is d dx of tangent of xy. Okay, all right. So now let's start with this first term. What is the derivative of tangent? Don't worry about what you're taking the tangent of. Right now, just ask yourself, what's the derivative of tangent? Well, it's secant squared. And then what do? Evaluate it at whatever the tangent was evaluated at. And then by the chain rule, you have to multiply it by the derivative of the inside. Okay? We'll do that in a second, step by step. What is the derivative of 3x? It's just 3. We don't have to throw in a dy dx because it's a function of x that you're differentiating with respect to x. And then what's the derivative of 4y? Well, it's a function of y that you're differentiating with respect to x. So first write down what the derivative is of the function as if you differentiate it with respect to y, and then you throw in a dy dx. Okay, I'm saying this in multiple ways to try and get you familiar with all ways of thinking about this. Okay, and now what's left is to differentiate x times y. I said the word times, so obviously you have the product rule. But make sure you put a parenthesis. Okay, so what's the product rule say? It's a derivative of the first times the second plus the first times the derivative of the second. And that is 3 minus 4 dy dx. Okay, well, there's really nothing to differentiate because it was just x times y. So if you want to ask what's the derivative of y with respect to x, that's just the dy dx. Okay, what's the derivative of x with respect to x? That's just 1, of course. So you have secant squared xy times y plus x dy dx, and that is 3 minus 4 dy dx. Okay, all right. Now distribute and solve for dy dx. And what do you have? You will have y secant, first let's just distribute secant squared xy plus x secant squared xy dy dx equals 3 minus 4 dy dx. Okay, obviously this guy and this guy are the dy dx terms, and this one and this one are not, so bring this over here, bring that over to the right, and you will have just dy dx times x secant squared xy plus 4 equals 3 minus y secant squared xy. Okay. So, solving for dy, skipped a little step over here in algebra. You can fill in the gap. You'll have dy dx equals 3 minus y secant squared xy all over x secant squared xy plus 4. And that is the derivative of, that is the slope of the tangent that you have on the curve. Okay? So if you want to find, for example, what's the slope of this tangent line over there, we'll plug in x equals 0, y equals 0 into the function you have over there, and you will see that actually it turns out to be 3/4, and that's the graph. That's the slope. I didn't do a good job of drawing it here. Yeah. Okay. All right. Okay. Now, next question we're gonna do is gonna be one step further, where we're gonna find the second derivative of y with respect to x. So how do you do that? First you'll find dy dx, and then you'll take that and differentiate it again. Okay, so in this, what we do is, first, we will find dy dx. Then differentiate that with respect to x again. And then there's one little final thing we'll need to do in the answer, where, but we'll talk about that when we come to it. Okay, so let's see. You have y equals sine of 3x plus 5y. I was really stuck to 3x in these examples. Okay, so you want to differentiate both sides with respect to x. Okay, so you'll have a dy dx, I mean there's nothing to do, it's just a dy dx, equals d dx of sine 3x plus 5y. Okay, this side is just dy dx on the left, there's nothing to do, so we'll just write it as dy dx. And the right side, what's the derivative of sine of something? Well, it's the cosine of that something times the derivative of that something. Okay, so it will be the cosine of that same something. Now, what's the derivative of 3x plus 5y? Well, it's the derivative of 3x plus the derivative of 5y, both with respect to x. Okay, and don't forget a parentheses, because you need to multiply all that by the cosine 3x plus 5y. Okay, so you have cosine 3x plus 5y. What's the derivative of 3x? That's just 3. What's the derivative of 5y with respect to x? Well, write down what the derivative would be if you were doing it with respect to y, which is 5, but then you multiply it by a dy dx. Okay, so you have dy dx equals that whole thing, and we want to solve for dy dx, so you'll have dy dx equals 3 cosine 3x plus 5y plus 5 cosine 3x plus 5y dy dx. Okay, solving for dy dx, and get used to this algebra slowly, or fast really. 1 minus 5 cosine 3x plus 5y equals 3 cosine 3x plus 5y. Okay, at this point, you can pause the video, make sure you fill in the gap, and then move on. Okay, so then you have dy dx equals 3 cosine 3x plus 5y over 1 minus 5 cosine 3x plus 5y. All right? That's only part of our answer, because that's only part way done. because we wanted the second derivative, not the first. Okay, so we now need to differentiate this one more time. Okay, so we know the second derivative is the derivative of dy dx. Okay, so what do? Differentiate both sides of this equation with respect to x. Okay, so the left hand side is d dx of dy dx. All right, and the right hand side is this d dx of this expression. Okay, all right, the left-hand side, like we've seen, is just the second derivative that we wanted. Now, what is the right side? Well, for the right side, we'll have to use the quotient rule. Okay, so that's the top and that's the bottom, f and g, so it is f prime. So I'm just going to write it as d dx of 3 cosine 3x plus 5y times the bottom. It's going to be a long looking thing. I have to start writing very small for this. Minus the top times the derivative of the bottom. It's getting squishy. Okay, all over the square of the denominator. Okay, now anytime you see a thing of y, you'll have to throw in a dy dx, but don't get bogged down by the details. Just first you have to do this derivative and you have to do this derivative separately. Okay, what's the derivative of 3 cosine 3x plus 5y? Well, 3 is a constant that stays. What's the derivative of cosine? It is minus sine. It'll be at the same thing. And then you have to throw in the derivative of 3x plus 5y times 1 minus 5 cosine 3x plus 5y. Okay. Okay, and then minus 3 cosine 3x plus 5y. Now we're going to do this derivative. And what will that be? The derivative of 1 is 0. Negative 5 cosine 3x plus 5y. So you'll have a minus 5. And then you'll have a minus sign. So that becomes a plus. And you have to throw in the derivative of 3x plus 5y. Okay. Okay, and then the whole thing is divided by 1 minus 5 cosine 3x plus 5y, the whole thing squared. Well, what is the derivative of 3x plus 5y? We've already seen this. It's a derivative of 3x, which is 3, plus 5 times 5, which is the derivative of 5y with respect to y, times dy dx. Okay, so
That's what we will use in all of these. Okay, so 3 plus 5 dy dx, and I'm going to substitute all of those with this. Okay, but we've seen this before too, so I'm erasing it. All right. Okay, that's the second derivative y with respect to x. It's big, and I'm not asking you to simplify it. However, something's a little bit amiss in this, and this is what I had mentioned in the beginning of the problem that we need to remember. You see, what we have over here is a dy dx. So what do we do with that? Well, what we do with that is replace the dy dx with this term. Okay, so all the dy dx's you see with that. All right. Be sure that when you replace it, this denominator over here comes down here, but don't just cancel it with that because there's the plus 3 over there. So it's a little bit more involved, and you have to make sure that you don't mess up with the algebra. Obviously on a test I'm not going to give you something so long, but I want you to note that even if you have to find the second derivative, don't just leave the dy dx in there. Use what you found for the dy dx in the previous term. I'm not going to write it in there and rewrite the answer. It will get much longer than the page. I mean, okay, I can actually do that. Let me just do that. Okay, so you have d squared y dx squared equals, let's put the denominator like this. Okay, and then you will have it multiplied by, now open it up, 3 times 3 minus 9 sine 3x plus 5y. Okay, then you have 5 times negative 3, which is minus 15 sine 3x plus 5y. Then you have to multiply it by the dy dx, so you'll have 3 cosine 3x plus 5y over 1 minus 5 cosine 3x plus 5y, but that's just one of the parentheses. Then you also still have to multiply it by 1 minus 5 cosine 3x plus 5y. Okay, so you see this thing is already getting a little crazy complicated to write down, and then minus, you have to now write this term out, and so you will have minus 45 sine 3x plus 5y cosine 3x plus 5y minus 5 times 5 times 3, 75 cosine 3x plus 5y times a dy dx, so it is 3 cosine 3x plus 5y over 1 minus 5 cosine 3x plus 5y. Okay, so you have, that's the second term, and that's it. So, you know, the point wasn't really this part. The point was, once you find the second derivative, you have to replace the dy dx with whatever you found in the beginning part of the problem, okay? Yes, I know this was very complicated and long, but just really trying to demonstrate all the skills that you need to use and make sure you're comfortable with. Okay? Well, don't get bogged down by the last step of replacement and the complex, crazy expression we got. Don't worry about that, but just know the idea of what I'm talking about. All right, well, thank you guys, and I hope that this helped you understand how to do some of these problems. Okay, bye.